Hey everyone, my name is Jakara Lewis. I know y'all so tired of hearing me say that, but I have to say it every time for all the people who are new to the group. Oh, 1 second. But I have to keep saying it for everybody who's new to the group so everybody can get to know me and they're able to say my name on a regular basis. So I am the author of the Kiss It series, TEAS Math Edition. KISS is an acronym for Keep It Super Simple, and the reason why I decided to create my own book is because for years I tutored for this test and I just had a really hard time finding materials that I felt like were good enough to help a student pass. So I had to pull resources from here, there, put together my own binders, and it just became too much. So what I did was I took all of the things that I felt like were essential for passing this test and I put it all in one space. So the book includes over 1,400 practice questions, a diagnostic test. Ooh, I have to sneeze. Whew. Oh goodness. Sorry. Oh goodness. Sorry. All right. So the book includes over 1,400 practice questions, a diagnostic test, 2 full-length practice tests, all of the oh god, my allergies bother me so bad. So sorry. All of the concepts that are featured on the test can be mastered between 1 and 3 steps. There are checkpoints along the path of the book, so I organized it into 5 clusters, meaning that I grouped together topics that were similar in terms of how you saw them, so that it's easier for you guys to be able to retain. So right now we are on cluster 3, and we're looking at the second topic. Cluster 3 isn't as much arithmetic as all of the other topics were. So like in cluster 2, we did ratios, proportions, and percentages, and all that. Of course, is going to be tons of actual math here. It's math and thinking. So if you guys look at the last video that I did, which was determining the relationship between 2 variables, that didn't have anything to do with actual arithmetic. That was just more concept and thinking. Now we're going into evaluating information in tables, charts, and graphs using statistics. So when we talk about statistics, it's real light for this test. Only thing you really have to worry about is mean, median, mode, and range, and you have to be able to look at a graph and be able to identify the shape of the distribution. Sometimes I see other people practicing for the test, and when they talk about statistics, they go so far into like standard deviation, they do stem and leaf plots, and they do box and whisker plots, and it's just not that deep for this test. I have to keep saying it over and over and over again. This entry exam is not the level of difficulty that a lot of people have led you guys to believe. A lot of other people who put together practice programs, they give you too much content. They give you things that are far beyond the level of difficulty of this test, which really annoys me sometimes, because then it makes you feel like you have so much stuff that you have to study, when the reality is that they tell you the 15 topics to focus on. And even if you go through like some of the practice problems or even some of the ATI stuff, the level of difficulty is not that bad. And sometimes you guys have to really be aware of the resources that you use, because sometimes it'll put you in a boat to where you're overthinking, you're overstudying, when you can be dedicating a lot of that time to mastering the content. So today, when we talk about evaluating information in tables, charts, and graphs using statistics, we're going to learn how to calculate mean, how to calculate median, how to calculate mode, how to calculate the range, and how to classify the shape of a distribution. So all in all, most of us should be pretty decent with this. The good thing is that because they provide you guys with the calculator, you guys should be fine. There's just a lot of small things that people tend to miss with these, and we want to make sure that we put you in a space to where this is a given, meaning that you've mastered it so you can automatically give yourself the point, because you're really not that likely to make a mistake, okay? So of course we'll go over definitions, because you guys have to know what the words mean. Sometimes people always confuse mean and median, so just make sure, if you might want to make you some flashcards or whatever it's going to take for you to be able to understand what the words mean, you have to know, because they may give you something in word problem form. They may not use the word mean, maybe they'll mean average. They may not use the word median, they may say the value that's in the middle, and you have to understand how to decipher, okay? All right, so the mean is going to be the average of a data set. All of us are pretty familiar with how to find the average of a number, and that's the kind of space you have to put yourself in. Don't get so technical, don't get so caught up in a lot of the math vocabulary. Just make sure you understand what to do when you see, I'm always losing my markers. What to do when you see it. So, and then I lost my big one. I didn't lose one though. Alright, so we know that the mean is going to be the average. So basically, anytime they give us a data set and they're asking us to find the mean of that data set, you just add them all up. And then you divide by however many values are in the data set. Right? So say if they give us a data set, I don't know. Oh, yes I do. I can just use the one that's right here. So we have 2, 6, 8, 4, 6, and 10. So let's say if we had 6 values in our data set and they ask you to calculate the mean. So we know, I always tell people just set up a fraction. We know that we have 1, 2, 3, 4, 5, 6 values in the denominator. So I know I'm going to divide by 6. And then we're going to add all these together. So if we do 2 plus 6, 2 and 6 is 8, 8 and 8 is 16, plus 4 is 20, 20 plus 6 is 26, plus 10 is 36. And of course, I always recommend that you use your calculator because when you're under the testing conditions, you are more likely to make a mistake, okay? So even if I was taking a test, I still would use my calculator because again, when you're in control situations like that, you're more likely to make a mistake. And then we know that 36, why is it so long? 36 divided by 6 gives us 6. So that means that the mean or the average of this data set is going to be 6. So when it comes to the mean, it's not really a lot that you have to know. You just have to know that when you see it, you add them all up and you divide by however many values that they give you. The only other thing that would be a little different is it would just be the way that they present it to you. So they may give it to you in a real world context versus just giving you a data set. And I think that's the part that throws people off sometimes, that when they introduce those real world scenarios, and it's kind of like, what are they talking about? And you don't want that to be a problem. So just making sure that concept wise you understand what to do when you see the word, and you should be fine. All right, let's say, for example, if you were taking a test and they gave you a table and it says student test scores, and of course this would be the actual test scores, and they ask you to calculate the mean. So you see what the difference is? The only difference is the presentation. Again, sometimes when people see things outside of the way that they practice, so if it looks a little different, it kind of scares them a little bit. But the concept does not change. And I'll say that in every single video that we do, no matter how it looks, how it's presented, the actual way that you solve, that's not going to change, okay? So you have to know that when I look at this, I'm not even worrying about the table. I see numbers, and if they say find the mean, I know, boom, add them all up and divide by however many values I have. So I have 1, 2, 3, 4, 5, 6, 7 values. And if I add all these up, 26 plus 34 plus 32 plus 23 plus 17 plus 29 plus 19, that's going to give me 180. And then when I divide it out, it's going to give me 25 point. Oh, that's not even a 7. 7. Y'all might have a real hard time writing upside down, so just bear with me sometimes when I do that. All right, and of course it'll be 25.7. So in this case, another sub skill that's definitely going to be really important is going to be our estimating and rounding. So make sure sometimes you may end up with a long decimal. You have to know how to estimate, because they may ask you to round to the nearest 10th or round to the nearest 100. So again, that sub skill is going to be really important. I tell you guys all the time, sub skills sometimes make the difference between the wrong answer and the right answer. I don't want you to get into a boat to where you know how to do all of this, and then when we get to our last part, you don't know how to round, and then you miss your question. Okay? And I definitely don't want that to happen. All right, moving on. Now we're going to talk about the median. So the median is going to be the value that is in the middle of a data set, what the median does is it cuts that data set in half, okay? The way that I always remember the median is if you know how you drive on the highway and you have like that little patch of grass, like those metal rails in the middle, or even when you're driving down a regular street and it's like that thing that separates both sides, that's the median, like we all know that, and it's in the middle. That's the good way for you guys to be able to decipher between mean and median. If that doesn't work, I always tell people, remember one of them, so you know when you see the other one is opposite. So if I know mean is average, okay, so when I see mean, I do the average. And if I see median, okay, then I know, okay, that's not the mean, so that has to be the one that's in the middle. I know I talk so fast, I really have to slow down, so sorry. All right, so median is the value in the middle of the data set. All right, so the trick with the median is that you have to remember to put the values in order from least to greatest before you choose the middle one. I think that's the most common mistake that people make with the median is that they don't remember to put the values in order from least to greatest, okay? So always, and I'll turn around so you guys can see, arrange in order from least to greatest. You have to do that. All right, so the median is going to be the value that's in the middle of the data set, and you always have to arrange it in order from least to greatest before you can choose the middle number. Okay. All right, so if we look at the same value, well, no, we won't look at that one yet. Let's say if we have a data set 2, 4, 6, 8, and 10. All right. So I have 1, 2, 3, 4, 5 numbers. All right, so this is the thing you have to remember with the median. If you have an odd number, I don't even know how to say an odd number data set. If you have a data set with an odd number of values, then your number should fall exactly in the middle. It's going to be one number that falls in the middle, right? The way that I do it is I always tell people, this one is kind of straightforward, but if you have like a longer data set with like 10 or 20 numbers, you always just cross the numbers out on the end at the same time. So I know, okay, boom, pair and pair. Okay, pair and pair. And that leaves me with the 6. Okay, I know it's a lot easier when we only have 5 values because you can basically see the 6s in the middle, but when you have a bigger data set, it's a lot harder. So if you scratch them off from the side and you work your ways inward and scratch them off in pairs, then you'll be fine. All right, so it's real easy when we have an odd number of values. So here we have 5. Now let's say if we had 2, 4, 5, 7, 9, and 10. Probably should do that one in color. All right, so if we had 2, 4, 5, 7, 9, and 10. All right, so in this data set, we have 1, 2, 3, 4, 5, 6 values. So whenever you have 6 values, there's never going to be one value that's actually in the middle that's going to cut it in half, okay? So what's going to happen is as you work your way from side to side, you're going to find that with an even number of values in your data set, you're going to end up with 2 numbers in the middle, okay? Because if we do pair and pair, that's 1. Pair and pair, I know I can't pair these off because then I won't have any numbers left. So when you are left with 2 values in the center of your data set, what you have to do is you have to find the mean of these 2 numbers, or the average. The easiest thing you have to know is just that if you're left with 2 values in the center, you just add them both up and divide by 2. That's the same thing as the mean. And we know 5 plus 7 is 12, and 12 divided by 2 is 6. So the median in this case will be 6. Now, is there anybody who has a question about that, who doesn't understand that? Of course, if you go back and you watch it while I'm not actually live, drop a comment just so we can decipher. So I want you guys to see the difference. So again, if I have a data set with an odd number of values, like the first one, so we have 1, 2, 3, 4, 5 values, right? There's going to be one number that's in the middle, and you just cross them off from the ends and you work your way inward, right? When I have an even number data set, so here we had 1, 2, 3, 4, 5, 6 values, there's never going to be one number in the center. There are always going to be 2. So what you have to do is you have to find the average of those two, which means you just add them up and divide by 2. So we did 5 plus 7, and we got 12, and 12 divided by 2 is 6. Okay? And that's pretty much the gist of the mean. It's either going to be one number stuck in the middle, and that's great. If it's 2, you just find the average, and I think this is the one that kills people sometimes because they forget how to do it, okay? And you don't want to make that mistake. All right, let me check to see if we have any questions before I move on. All right, cool. So, moving on to our next one, which is going to be the mode. And I know we have all these M's, that just completely just throws everybody out. All right, so the mode is going to be the value that occurs or repeats the most in a data set. And that's pretty straightforward. So the thing with the mode is you can have one mode, you can have multiple modes, you can have 2, 3, or 4, or you can be in a situation to where you don't have any modes at all, okay? And now I'll show you guys examples of that. So again, if we look at that same data set, we have 2, 6, 8, 4, 6, I don't know where I got 16 from, 6, and 10, right? Stop putting those commas. All right, just in looking at this, we can obviously see that 6 is repeated twice, 2 isn't, 8 isn't, 4 isn't, 10 isn't. So in this situation, 6 will be our mode, okay? Very simple. Now, what if we had this situation? We had 2, 6, 4, 2, 6, and 8. Well, I already see that 2 is repeated twice, as well as 6 being repeated twice. So in this instance, the mode will be 2 and 6, okay? And that is possible for you guys to have more than one mode. Sometimes you can have 3 modes, you can have 4 modes, as long as they're repeating the same number of times. Now, say if we had an extra 2 down here. Okay, now my 2 is repeating 3 times, so this is the mode. So don't get don't get confused and think if a number occurs more than one time, that makes it the mode. No, it's whichever number occurs the most. So if they happen to occur the same number of times, then they're all considered the mode. Okay? And then there could be one last situation. So we can have a data set like this, 2, 4, 6, 7, 8, and 10. So of course, nothing repeats, so we don't have, this will be a situation to where there is no mode, okay? So we can have a situation with one mode, multiple modes, or no mode at all. And I know some people say, oh, they all occur one time, so wouldn't they all be the mode? Nope. Not in this situation. You have to ask the people who came up with all this stuff. All right, and our very last one is going to be the range. And the range is just the difference between the largest and the smallest value in a data set. All right, so the range is going to be the difference between the largest and smallest value data set. The easiest way to execute these to me is to put them in order from least to greatest first, and then you just pick the last number and the first number and subtract. Some people can do it without doing that. The only problem that I have with that is that when you don't actually put them in order from least to greatest, Oh my God. Oh, no. Did I? Because now I'm trying to think when I did the median. No, but I did have them in order from least to greatest. I'm going to have to go back and watch the video. I'm more than sure I did. More than sure. I don't remember. Probably. Okay, sorry. I just completely went way off track. I do that sometimes. So my advice is always to put them in order from least to greatest first, and then subtract the numbers on the end. So for example, if we have the same data set that we've been rocking with, we have 2, 4, 6. No, we have 2. What's in a different order? 2, 6, 8, 4, 6, and 10. If we rearrange them, it's going to give us 2, 4, 6, 6, 8, and 10. And of course, the range is going to be the difference between our largest and our smallest values. Those will be the 2 values on the end. And 10 minus 2 is equal to 8. And then there are no tricks with range. It's just making sure your computation is right. So use your calculator. All right, so one more time, the range is going to be the difference between the largest and the smallest value in the data set. I recommend that you put them in order from least to greatest first, and then you just subtract the 2 numbers on the end, and that'll give you your range, okay? The only mistake that I've seen most commonly with this is that people just will miss, they won't subtract right. So just use your calculator. I know even if it's something that's super simple, still use your calculator so that you won't make a mistake. Alright. Alright, and the last thing that you have to know for evaluating data using statistics is you have to be able to, oh shoot, I gotta sneeze again. You guys have to be able to identify a distribution based on its shape. So I'm gonna do like some rough drafts. Now I'm not like Picasso or anything, so they're not gonna be like amazing, but you'll get the gist of it. Alright, so this will be an example of a graph that is considered normal or bell-shaped. That just means that it's, if you bust it in half, it's symmetrical on both sides. And in this case, the mean will be equal to the median, so you have to know that. You have to know that. If they put you in a scenario and they give you a graph and they ask you, well, what's the relationship between the mean and the median? You should know. Or they may ask you to identify, is it normal or bell-shaped? They won't give you like both of them. It's normal and bell-shaped is the same thing, okay? But this is what you guys are going to have to know, so make sure if you are watching this video, either make you a sketch and do your notes, or go to Google and Google shapes of distributions. Matter of fact, I'll see if I can find one and I'll upload it to the file so that you guys know it. So know it, love it, learn it. Because these questions can be pretty simple, but it's all a matter of memorizing them. So again, this is a normal or bell-shaped graph, and in this situation, the mean is always equal to the median, okay? All right. Hey, how you doing?
Good.
How you been?
Good.
Congratulations.
Thank you.
All right, so this graph is considered to be uniform. So here, there's no relationship between. No, you're all right. Here, there's no relationship between the mean and the median, but you have to know that if all the values, and they say uniform, that means it's all the same. Sometimes it can be slightly varied. So let's just say if it was like this one was a little bit higher, and this one was a little bit higher. In general, it's still uniform because most of them are very similar. Okay. That's basically what you guys are looking for. And in this situation, uniform graphs, there's no relationship between the mean or the median. And altogether, there are going to be 4 graphs. They're going to be looking for you guys to know when you see it. Again, you have to know the shape of it, and you have to know the relationship between the mean and the median. You looking for something in particular?
I'm going to Mexico Monday, and I don't have.
Now, why you waited this late? That is crazy. You looking for a swim like beach stuff?
Not. I have my swimsuits. I just don't have anything to put on.
Like nothing?
Like nothing.
What you want? Dresses? What you want?
Dresses, whatever. At this point.
I have some of those, the long dresses with the pockets.
Yeah, let me see those.
I have them in pink and white. Just the pink one. These are ones that you can wear like off the shoulder, like one shoulder or two shoulders. Let me finish this video real quick.
Okay.
And I got that white too.
Okay, I like this. I think I'm gonna get the white one, cause I got a dress this color.
Okay.
The white one. It's cute.
Yeah.
And I need some sandals.
What size are you?
A 10.
I got 110. No, I'm lying. Oh, 2 10s, but they both in white though. Alright, so this is an example of a graph that's going to be skewed to the right or positively skewed. So I put both names because you guys have to know both variations because it can be in either. It could be presented to you either way. So I know sometimes people say, well, oh my goodness, with this one, how can it be skewed to the right, but it's going down from left to right? So the reason why they say it's a skew is because this is where the tail is. Again, I don't know who comes up with this stuff technically, but just know that you have to know it when you see it, that this is skewed to the right, not to the left. So kind of like the opposite of what you see. All right, and in this situation, the mean is always going to be greater than the median. So these, when I put them in color at the bottom, those are the things that are really, really important. Is understanding the they can see. Is understanding the relationship between the mean and the median. All right, and then if we switch it around, of course, skewed to the left is going to be the opposite. So it's going to rise from left to right. And in this case, the mean is going to be less than the median. So again, because the tail is on the left-hand side, that's why I assume that they say that this is skewed to the left. It's on the left-hand side. And or it's negatively skewed. So again, you have to know the difference between the two names, left or negative, because they mean the same thing. And in this instance, the median is greater than the mean. And that's pretty much the gist of what they expect you guys to know in terms of evaluating information in tables, charts, and graphs and statistics. So far, today you guys have seen how to calculate the mean, how to calculate the mode, how to calculate the median, and also how to calculate the range. You guys also have to be able to look at a graph and classify the shape of its distribution, along with being able to determine the relationship between the mean and the median. So this particular topic, you won't see a lot of, but at the least you'll see one question like this, okay? Maybe two. So just make sure you put yourself in a space where you're studying and you're practicing, and you should be good. Our next topic is going to be interpreting relevant information from tables, charts, and graphs. So basically that just means that they give you a table, chart, or graph. You have to be able to answer a question in reference to it. Now this particular topic includes tons of sub skills. So you guys could be dealing with percentages. You guys could be dealing with statistics. It's so many proportions, ratios. It's so many different ways they can throw these at you. It's so many ways, honestly, that it's really hard to actually teach for this part. You just have to go through tons of different examples so it can put you in the right situations so that you're aware, along with sharpening those sub skills that we always talk about. All right, so I'll probably do the next video in another hour or two. I always have to kind of take a break. I may do geometry prior to that, only because it's a lot harder for me to draw the tables and the charts. And I'll make sure that I add those extra files for you guys for the shapes of the distributions. And of course, if you guys have any questions, or if you've seen any questions in any other groups, drop them for me, and I'll do a video so I can show you guys how to complete them. Thank you.
Oh, why are you laughing at me?